All right, graphing rational functions and determining the limit when infinity is resolved. So that's why these are important. So the first thing to do is always factor and cancel and see what you really have going on with your function. That's what you want to do before you do anything else. I'm not asking for domain here, just x and y-intercepts, any holds and asymptotes. So the first thing I'm going to do is factor, and I can factor the denominator. Here the denominator, x squared or plus 7x plus 10, that factors to x plus 5, x plus 2. So the x plus 5s are going to cancel, and I'm left with 1 over x plus 2. Since I don't have a variable in my numerator, I don't have any x-intercepts. And we're still finding the limit, so I still need that limit notation in here, limit as x approaches 2. And we want the limit from the left and from the right. We want to see what the behavior of this actually is. Okay, so the y-intercept is what happens when I put 0 in for x. So I find that by doing 1 over 0 plus 2. So that is 1/2. So 0, 1/2. I'm going to go ahead and plot that point because I have it. So over 0 up 1/2. I did have a removable discontinuity. My removable discontinuity happened when I could cancel that x plus 5. So that gives me an x value of -5. And the y value I get by plugging 5 or -5 into my canceled expression. So my canceled expression was 1 over x plus 2. If I do -5 plus 2 in the denominator there, I get -1/3. So I can plot that point as well. Of course, it's going to be an approximate. So -5, -1/3 is a whole. Okay, we're starting to come together here. Vertical asymptote. My vertical asymptote is at x equals -2. We set the denominator equal to 0. And my horizontal asymptote, since this is a bottom-heavy fraction, my horizontal asymptote is going to be at y equals 0. So I have a lot of good details here. This looks great. Now, to figure out what our limit is, all right, so little typo on this problem. I actually wanted us to do the limit as x approaches -2. So sorry about that. That's why we need to deal with this asymptote situation so specifically. So now we need to make a table to figure out what our function really looks like at -2. In AP Calc, and Calculus, you'll be doing this without a calculator, which is why we're not going to pick up our calculator right now. And we are going to see what the behavior is around this asymptote. All right, so in order to figure out the behavior around this asymptote, we have 2 nice points. And what we really need to do is figure out what our graph is doing as it approaches -2 from the left and from the right. So we know what's going on at -5. So I'm going to just make my little input-output table for -4, -3, -2 we know is an asymptote, -1, and that should really do it for us. We already know what's going on at 0. At 0, our y value is 1/2. And we can use our canceled fraction. That's the easier one to work with. So let's go ahead and use that. This should give us the behavior as we're approaching that asymptote from the left and from the right. So we'll be able to see whether our graph is going to cross that horizontal asymptote and kind of do something we don't expect, or whether the graph is going to do what we expect. I would expect from the left that our graph is going to go to negative infinity, since our hole at 5 negative 1/3 is below that horizontal asymptote. And from the right, I would expect our graph to go to positive infinity, since our our y-intercept is above the horizontal asymptote. But we know that our graph can cross the horizontal asymptote at discrete points, so that's not a guarantee. Okay, so let's plug in some numbers. All of that said, let's plug in some numbers and see what's happening. And we're plugging into 1 over x plus 2. Why not use the simpler right here? So I'm going to do 1 over negative 4 plus 2. And that gives me negative 1/2. So at negative 4, my y value is negative 1/2. At negative 3, 1 over negative 3 plus 2. So that gives me negative 1 over 1. So 3, negative 1, negative 3, negative 1. And you could even do, if you weren't 100% certain, you can do negative 3.5, negative 2.5 as well. But here I can see the trend, I can see what's happening. This guy is taking a dive to negative infinity. So the limit as x approaches negative 2 from the left of our function, and we'll just call it f of x so I don't have to rewrite all of that, is negative infinity. Okay, let's see what's happening from the right. So we know at 0, our value is 1/2. At negative 1, when I plug in negative 1 plus 2, negative 1 plus 2 is 1, I get 1 over 1. So my point is negative 1, positive 1. Again, we could plug in negative 1.5. We could plug in 1 and figure out what that value is. 1 over 1 plus 2 is 1/3. So at 1, we're at positive 1/3. So our curve on this side looks like this. While you're practicing, you can definitely check on your calculator. So the limit as x approaches negative 2 from the right of our function is positive infinity. So our two-sided limit does not exist. Because our left-hand limit and our right-hand limit are going to be their respective to negative infinity and positive infinity. We don't know that without filling in all these details. We don't know that without looking at the intercepts. The removable discontinuity was helpful, and the asymptotes. All right, that's number 14. We'll do number 15 next.